Hi class. My name is JustusM. Today we're going to be learning a little something about micropropagation of cauliflower. Now, micropropagation is a form of asexual reproduction, but it's like it's more sciencey. It's a little more it's a way to produce from plants that aren't as ready to just produce like that. So it's just, you got put them in a petri dish, give them a little bit of some nourishment so they can survive for a little until they can root, and then you can transfer that into something else. So that's what this is. That's what we're doing today. These are my objectives. I'm going to address what micropropagation is, explain the steps, explain some of the materials. Even though we don't have any of those for real, this is just kind of for fun demonstration to get kind of a feel for what micropropagation is and how it's done. But that's what today is. So, alright, I'm using some salad dressing as agar today because I did not feel like buying it and then preparing it because it's hard. But if you guys, I'm just going to pass this around. If you guys could just fill your empty bowls with some, not like a lot, just like the bottom, because it's representing the agar, and the agar goes to the bottom of the petri plates, as I'm going to explain in a moment. All right, so agar is a solution that's made from seaweed in the ocean. It's a material that's found in the cellulose, membranes of the seaweed. So that's a major component. It's like what holds it all together. It holds the things up. It holds the explants up in the solution. So agar is important in most things with petri dishes. It's the main ingredient. Sugar is important in this thing because they don't have roots yet. This is just the inflorescence of a cauliflower, so it doesn't really have anything to hold. So it holds that. The sugar is there so they can feed meat, and stay alive. All right, Mershig stew solution. This is an important part of this thing because this is kind of what helps it work. It is what kind of contains all of the hormones that get this going, get this ready, get this callus, and get this rooting. And the callus is really one of the most important parts when it comes to micropropagation, because callus is the tissue that kind of is indeterminate tissue that kind of becomes the roots from the ends of the shoots and their stomach tissue. And kinetin is another hormone that goes into this mix. It's a pretty small part. It's a really you end up having to take out some of it, dilute it, and then mix it in. It's a very small amount. All right. So the most important thing about this, when you're doing it, is the aseptic technique, because you have all the things there that are needed to just produce any kind of mold, any kind of fungus. Any of these things will just take over anything you're making if you don't keep it absolutely clear. So we're skipping over this today, not because we should, but just because of the fact that none of this is going to grow. We're using salad dressing, so mold isn't really as big a deal, but it's the most important step when it comes to actually doing a micropropagation experiment, because if you don't do it properly, everything you're going to have is just going to be outcompeted and nothing's going to grow. So everything needs to be sterilized, from the workstation to every single tool you use, and there's steps involved in doing this that I will explain a little bit later, where you sterilize the parts of your explant. And if you're doing a petri dish, you're using a jar, because mainly these bowls are representative of a jar, and they don't have to be a fancy jar. I've used baby jars and stuff as this before, but they do have to be sterilized. And when you're trying to do it, you don't want to keep them open or anything like that. You want to make sure that no contaminated air gets around them, because that's where the spores will be. That's where the fungal contaminants really get into there. So you want to keep that covered as much as possible. Keep the air pollution down, and so that'll really keep your experiments running well. And so preparing explant, this is where we're going to be starting doing some things for real. So I'm going to use my real knife. Now, in this, you would use a scalpel, which is a very sharp object. You want to keep it clean, but you also want to make sure you're not using it dangerously. You're not trying to cut yourself. You're not trying to use it in any kind of way where you're coming back at yourself. So you're just going to try to cut a piece and keep so I have my piece like this. I don't know if any of you guys are ready. Taking notes or whatever, but so it's just, you want to cut a piece that's pretty small, small to fit into whatever you're using. We're using a bowl, so it's kind of big, but I would probably try to use a piece right around the size of this. You guys can see this. It's pretty small. It's like this. It's leaving a lot of exposed tissue in the bottom parts. It's mostly about trying to expose that bottom, make sure that, because that's where the hormones that are good will come in and then come down and form a callus. And again, callus is the most important part when it comes to micropropagation. So we really need that callus. I'm going to make sure the pieces are small and make sure that you know, like, this is up, this side's up, because you put it in the wrong way, so it might not work very well. So you got to make sure it's up, and then you're going to put it in the water, the bowl of water. That in real life would be this the STSEN solution, which kind of helps clean and open up the explant for further things. You can just drop that in the water with your chopsticks. I didn't bring it up for myself, so yeah, just drop your explant into that, and that has to be in there for 15 minutes just to really thoroughly clean. I don't have time for that, obviously, but you just put that in the water, make sure it gets good and clean, make sure your explant is ready to go. So, all right, just imagine 15 minutes has passed. All right, those explants need to be placed into your agar or salad dressing. You need to put them in, and you have to orientate so that the top is up, the top of this inflorescence is up, and then you just got to make sure that it's inserted into the agar, which makes more sense. The agar is kind of like a jelly or a jello, so like you kind of like cut it and put things into it. So like it really holds it there really well. This is kind of loose and dressing, so it doesn't do that. But that's the idea. This is a picture of. You can see this is a cauliflower. You can see there's some leaves coming off and stuff, and you can see like there are roots underneath the agar, which the picture's not really focused in on, but you can tell. And this right here is inflorescence, which is kind of what I'm talking about. I mean callus. I'm sorry. And these are my references now. Cauliflowers, I picked that one because it's a really interesting thing. Like it works in this kind of experiment pretty well. But it's also, it's a Brassilica oligra, which is that's the Latin name from the species. So the cauliflower is inflorescence. Broccoli is the bud. Brussels sprouts are like they're modified. It's all the same like plant. They're just like all been adjusted for different things. And because I am I'm trying to study and plant breeding and genetics, I'm really interested in that. The idea of using a plant, kind of changing plants to make them a little more useful for other things. So that's what this is, and that's my experiment, my demonstration. Thank you.